Hello everyone, welcome to my YouTube channel. Today in this video we'll learn types of probability. This is the second part of probability and its uses. So types of events first, we'll see disjoint event and non-disjoint events. Disjoint events, these do not have any common outcome. Like for example, the outcome of a ball delivered cannot be a sixer and a wicket. A single card drawn from a deck cannot be a king and a queen at the same time. A man cannot be dead and alive simultaneously. That's an obvious thing. So for non-disjoint events, these can have common outcomes. As a student can get 100 marks in statistics as well as in probability. The outcome of a ball delivered can be a no ball and a six. So now we will go to the rules of probability. These are the basic rules of probability. So the first rule is if A and B are mutually exclusive events, that there is no common element between A and B, then P of probability of A or B is probability of A plus probability of B. In the second rule, if A and B are not mutually exclusive, then probability of A or B is equal to probability of A plus probability of B minus probability of A and B. If both A and B are independent events, then A and B leads to probability of A into probability of B. If A and B are not independent, then probability of A and B is equal to probability of A into probability of B given A. Now the probability rules, advanced rules, these are, so for any event A, probability of A of not occurring is equal to 1 minus probability of A occurring. If A is a subset of B, then P of A is less than or equal to P of B. For any two events A and B, probability of A union B is equal to probability of A plus probability of B subtracted by probability of A intersection B. This is called the addition rule. When A and B are disjoint events, probability of A and B is equal to 0. Hence, probability of A or B is equal to probability of A plus probability of B. So the last rule is for three events, that is A, B and C. So probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of A intersection C and B intersection C plus probability of A intersection B intersection C. These are very important rules of probability that you need to understand and remember for further processing. So let's go to independent events now. What are independent events? First we'll know. So two events are independent if the occurrence of one, probability of occurrence of one does not change the probability of occurrence of the other. So an example for this is a rolling 2 on a die and flipping a head on a coin. These two are totally exclusive events. Rolling the 2 does not affect the probability of flipping the head. If events are independent, then the probability of them both occurring is the product of the probability of each occurring that we saw in the rules of the probability. The formula is probability of A and B is equal to probability of A into probability of B. Example of multiplication law of probability. So the first example is a bag contains 3 pink candies and 7 green candies. 2 candies are taken out from the bag with replacement. Find the probability that both candies are pink. So there are 3 pink candies and 7 green candies. So let's see how will be the solution go. So let A be the event that the first candy is pink and B be the event the second candy is pink. So probability of occurrence of A is 3 out of 10. So 3 is the total number of pink candies that are present, and total number of candies are 10. So 3 divided by 10 is the probability of A. Since the candies are taken out with replacement, that implies that the events A and B are independent. So probability of B to A is equal to probability of B is equal to 3 by 10. Hence, in the multiplication law, we get probability of A intersection B. As the events are independent, that is equal to probability of A into probability of B by A. Here B by A is not B divided by A. Probability of, so here probability of intersection of A and B is 3 by 10 into 3 by 10, that we get from 1 and 2 equation. So the total value is 0.09. That's the probability. So let's take another example. A bag has 4 white cards and 5 blue cards. We draw 2 cards from the bag one by one without replacement. So we have to find the probability of getting both cards white. So let A event be the first card in which all the cards is white, and B event that the second card is white. From question we see probability of A, probability of getting the first card as white is 4 by 9. And now probability of B is probability of B by A, because the events are dependent on each other. So probability of B is 3 by 8. So probability of A intersection B is totally 1 by 6. Thank you. For the next topics we'll see in the next video, and subscribe to my channel, and please like the video.